Hello friends, this is Anand Pai from Academy in Pursuit of Engineering Excellence. Today we will continue our questions on students recommendation. This is the question recommended by Manoj. He has recommended question 13 and 17. 13 I have solved it already, 17 I am doing now. The question is like this. Moist air having 60% relative humidity enters a steady flow air conditioning unit at 102 kilopascal and 30 degrees centigrade. The volume flow rate of the moist air entering the unit is 0.1 meter cube per second. The moist air leaves the unit at 95 kilopascal at 15 degrees centigrade and a relative humidity of 100%. Liquid condensate leaves the unit at 15 degrees centigrade. For water, the properties, saturated properties are given at 15 degrees and 30 degrees centigrade. So for air, specific heat is given and specific gas constant is given. So neglecting the heat leakage to the surrounding, the magnitude of heat extracted from the air stream is. Now here one thing we have to understand is this particular question is one of the questions which takes a lot of time. Generally for 1 mark question there is 1.8 minutes, okay, and for 2 marks question almost 4 minutes you take. This particular problem may take you to solve this problem, it may take more than 5 minutes. So I would recommend students to kindly do these kind of problems at the end after you finish off all the questions. And also there is a possibility that you may go wrong in calculations. So kindly do the calculation slowly. Okay, so let us solve this problem. First of all, one has to understand that whenever relative humidity is given phi, okay, relative humidity is given as equal to pressure of the vapor inside the humid air, vapor in the sense water vapor in the humid air, divided by, or I'll say P of water, that would be better, or vapor, let it be, pressure of vapor divided by saturation pressure of that vapor at that particular temperature. So now initially 60% humidity is given. So if I want to find out the pressure of the vapor, this is at state 1, okay, if it is at state 1, the pressure of the vapor comes as equal to P saturation into phi. And this P saturation here, if you see, 1 is at 30 degrees centigrade, P saturation is 4.2469. So we can take 4.2469 into 0.6, which is the humidity, relative humidity. Okay, so I'm sorry, I said this is a humidity ratio. I'm sorry, it is relative humidity. Okay, so this relative humidity is given as this. So the answer for pressure of the vapor, I got it as 2.54814. okay, you may ignore these two, that's fine. Okay, now first of all let us find out the humidity ratio. This is relative humidity and this is humidity ratio. Now if you want to see the humidity ratio W is given as 0.622 into pressure of the vapor divided by total pressure minus pressure of the vapor. Okay, and this will come as 0.622 into here 2.54814 divided by pressure, total pressure is 102 kilopascal minus 2.54814, and this together will come as, for me it has come as 0.01593. This is the answer what I have got. Okay, what is this? What is humidity ratio? Humidity ratio is mass of water vapor or mass of vapor divided by mass of air. This is humidity ratio, that has to be kept in mind. Okay, so next one. Okay, after this, next point we have to see is humidity ratio at 2, say W2, okay, is given as 0.622 into pressure of the vapor divided by total pressure minus pressure of the vapor. Now this PV here has to be the saturation pressure. Okay, so this is same as saturation pressure because it is coming at 100% relative humidity. Okay, 100% relative humidity means saturation. So that is why this comes as saturation. And the saturation pressure at 15 degrees centigrade is given as 1.7057 divided by 95 is the pressure, right? 95 kilopascal minus 1.7057, and the answer I am getting is 0.011372. This is the answer I am getting. Okay. Now, when you say mass of air which is going is actually equal to the mass flow rate of the air, okay, divided by specific volume. Okay. Now, mass flow rate, now here one of the main thing what has to be understood is, see, when the humidity ratio, which is mass of air divided by mass of vapor for the entrance or the exit, is in the order of 1 by 100, correct? So, or 1 by 50, say 0.016, almost 1 by 50 to 1 by 100 is the ratio. So, mass of vapor we can always neglect. The mass of air is almost equal to mass of vapor. So, we don't have to worry about whether it is moist air, whether it is dry air, such kind of things we need not worry. Okay. So, moist air, the Q is given as 0.1, correct, meter cube per second, yes. And specific volume of the air has to be taken. Now, here we can take use of the ideal gas. So, since PV is equal to RT, okay, P specific volume. So, specific volume is RT by P. So, we can take it like that. So, if I take RT by P here, RT by P. So, this would be equal to 0.1 divided by R is given as 0.287 into temperature, initial temperature is 273.15 plus the so I can say 303, I can say plus 30 degrees centigrade, and pressure is 102 kilopascal. The answer what I am getting is 0.11723 kg per second, correct? This is meter cube per kg. So kg goes up and kg per second is the mass of air there. Now, next, another point we have to take is the heat loss, Q12. This can be given as mass of air, moist or dry, we are not worried, okay, into H2 minus H1, the enthalpy. This is the initial enthalpy, this is the final enthalpy, plus, now when I consider the water vapor which is going out, water which is going out, this is given as, see, W is equal to M of vapor divided by M of dry air, correct? So, mass of vapor is given as W into MA, correct? So, MA is given here, and then I will say W say 2, okay, into, now it is going in the water state, correct? What is going is water state. So, what is the amount of water which has gone away, if you want to see, that is W2 minus W1. This much of water has left the air into the saturated, the enthalpy of saturated water at 2 when it is going out at 15 degrees centigrade. That is what we have to take. But here there is another catch here. This M dot A into H2, when I take, H2 has to be taken as, I will put another bracket here, okay. So, let me put, instead of this, let me replace this by a flower bracket, so that we will get better, okay. So, in the flower bracket, inside this bracket, another small braces I will have. So, this can, H2 can be written as Cp air into T2, correct, temperature. This gives the enthalpy from a particular base. We are not worried about the base, okay, plus, Now here when I take enthalpy, it is not just the enthalpy of air that has to be taken, it has to be enthalpy of water vapor also has to be taken. And generally water vapor, what happens, it has a high latent heat, so that latent heat together has to be taken. So W2 into Hg2, that is with the latent heat, along with the latent heat you have to take at the gas state. Now from this gas state, which is saturated gas state, to the final one, we do not know how much it goes, but still, because since it is very small, we ignore, because when you take, say from if I take the if I say PV diagram, okay, this is the saturation pressure. Now from here, this is the Hg, correct. From here it goes to a supersaturated state. When it is 60% saturated, it's supersaturation state. Now here this is very negligible compared to how much it has gained till here. So if I say H superheated, okay, H superheated and Hg, that is very small when in addition to air which is there, so it becomes not that important. So let us see, okay, minus H1. If I take H1, similarly we can take Cp into T1 plus W1 into Hg1, okay. So now this plus W2 minus W1 into HF2, okay. So this is the total one. So now this comes out to be m dot A into, I can write here like this, Cp into T2 minus T1, correct, plus W2 Hg2 minus W1 Hg1 plus W2 HF, or W2 minus W1, let me put it like this only. So W2 minus W1 into HF2 would be the thing. Now let us substitute this. We have to be very careful in substituting. So it is 0.11729 into 1.004 into minus 15 plus 0.11372 into 2528.3, which is W2 into Hg2, plus now minus W1. If I take minus W1 is taken as 0.01593, correct, 1593, which is what I got previously, and yes, 1593, correct, okay, and yes, 1593 I got. And then if I consider 1593 into 2555.6 plus we have W2 minus W1 0.01137 to minus 0.01593, okay, into 62.982, okay. This is the total one which I get. Let us see one by one what are these. Now here, if I consider the first one, I'll write this again. So this Q is equal to m dot A into Cp T2 minus T1 plus W2 into Hg2 minus W1 into Hg1 plus W2 minus W1 into HF2. Now let us see what it, after putting the values, this will come as 0.11729 into this particular thing will come as for me minus 15.08, okay, plus W2 minus Hg2 28.751, that is what I got. Then this one I will get it as 40.89 minus 0.2916. Now one thing we have to understand here, see, whenever we do the calculations also, we have to see some concepts. See, the heat which is taken by condensing liquid is very less compared to the heat difference between W2Hg2 and W1Hg2. So the reason why I have ignored the why I have ignored the superheat, the enthalpy of superheat I have ignored. Okay, the reason is here. See how big it is. Okay, and that is one of the reasons why I have ignored. Okay, and if you can compare, because of the change in enthalpy of the air is significant. You see, 15 change in enthalpy due to dry air is significant and is comparable to the change in enthalpy of the moist air. So you see, this and this is comparable, 28 and 40 around 12, correct? This and this is comparable. That has to be understood. So when I did the answer what I got was minus 3.20 kilowatt. This is what is the answer I got. The answer which is given in the answer keys is 3.01 to 3.07. Somehow I did not get that answer. There might be some calculation mistake or something, I am not sure about it, but the procedure is correct. Okay, so if you find any calculation mistake, please tell me. Okay, and thank you very much, students. And one more point, whenever you have you get this kind of anomaly in the answer keys which is given by the IITs after gate, kindly contest it. Say that you are not getting that answer. Okay, there is a time gap which is given by the IITs to check the answer keys and challenge their answer keys. So if such kind of things happens, kindly challenge it so that you will not lose marks unnecessarily. Okay, but I think this is correct, but if there is any mistakes what you think in the calculations what I have done, kindly bring it to my notice in the comments. But the procedure wise it is correct. Okay, so I hope students you have understood this. Any further doubts you can put it on the comments. We can start a discussion on the comments also, and if you have any suggestions that I have to make video on some topics or some questions till GATE 2021, I will be concentrating on questions only, or some small topics which you are giving, or some doubt clearance. On that only I will make videos, all on students recommendation. Okay, so thank you very much students, and all the best.